Good morning, everyone. How are we doing?
Good.
Good. Kenda and everyone else. Let me tell you a little bit about where we are. Then we're gonna start our class. There's a little bit of noise in the background. It should go away in probably 10 seconds. Okay, I apologize. So, guys, our final. I'm working on the study guide for the final. Let me change it right now. It should say study guide for final. So when is the final? It's on Wednesday, a week from today. And it will be available starting Wednesday, July 27th at 8 a.m. and will be available till 8 a.m. the next day. The sections that we plan on covering this will change. I may add a couple. If we do them, of course. If I don't do them, I won't add them. So that's where we are. Don't forget to take the exam. I won't be able to give you makeup exams. You don't want to miss your final. If you miss one of the exams or you have a low score on one of the exams, your final will compensate for it. Your final will replace the lowest exam score, but it will not be replaced by anything else. So if you have 100 on every exam, you still will have to take your final. Okay. Any questions about the final? Any questions? It's the syllabus is tentative, but these things will be there. We haven't done a few of the sections, but they'll be wrapped up today and tomorrow. Essentially, guys, we have 4 more lectures today, tomorrow, and 2 lectures on Monday and Tuesday, and then we have our final. All right, guys. Again, you can ask any questions about MATLAB, about our text anytime. And we're going to work on I believe we wrapped up 2.5, which was transformations. We're going to work on 2.6. And the good news is 2.6 is not a difficult section. Okay. And I'm going to get my tea and I'll be right back. Okay, guys. So the section we are starting is called combination. The word, let's make it a little bigger. Combination of functions, which is a very easy concept. Okay. And composite function, which is slightly harder than combination of functions, but not really that hard. Now, next section 2.7 is about inverse function. Some of you will find it a little challenging. Okay. So guys, we're going to be dealing with functions that are a little more complex than what we have encountered so far. Okay. So we're going to talk about, and we will have to find the domain of those functions. Interestingly enough, they don't want us to find the range. We're going to just work on the domain. So there are 2 things you really have to remember. Okay. When it comes to domain, I'm going to take it on my polypad. I'm going to save it here. Again, this is 2.5, composition of function, combination of functions. Before we get to our main topic, we're going to talk about domain. So take 2 things you have to understand, only 2. If I give you anything like this, we haven't seen this kind of function too often, but this time we will. Now, the bottom cannot be 0. Okay, what does that mean? If x is 5, x minus 5 is 0, and that's a problem because in math, we cannot divide by 0. So to find the domain of this function, any number, you can replace x with any number, you will get a value. Okay, there is one bad guy that you cannot replace x with, and that's 5, because x minus 5 is 0 means x is 5. And that's a problem. So how would you write the domain of this function? You could do it, you could say it in English, all real numbers except for 5. You can say that. Generally, we write it this way, and your book uses this notation. It will say everything from -infinity to +5, and parenthesis, not square bracket. Then starting again with 5, goes all the way up to infinity. Now, generally, these are two different intervals. We link them by saying union. The same union we talked about, union intersection. So that's how we are going to write it. Let me give you one more example. Well, let's pause there a little bit, just a little bit, to see if people understand what's going on. I'll give you a couple of more examples, and you really want to get it, because if you get it, all the problems we will do, this thing will come back over and over again. Okay, so any questions, guys? Let me give you another example. Okay, let me erase this. This is really the same topic. You cannot divide by 0. So this time, I'm going to give you this function and ask you to find the domain of this function. Okay, so if you have a denominator other than 1, that's very important. Ask yourself what value of x makes the denominator 0. The answer is, if you replace x with 1, you're in trouble, because this is going to make it 0, a bad guy. Or if you replace x with -1, you're also in trouble, because that will make x plus 1, the whole thing, 0. So I have two bad guys. They cannot be a part of my domain. What does that mean? If I replace x with these numbers, I don't get a value for f of x. So how do I write it? I'm going to take the smaller of the two, which is -1. I'm going to start with negative infinity, go all the way up to -1. I'm going to put parentheses. Then I'm going to start with -1, all the way up to 1. Put parentheses. It's ordered. Okay, -1, infinity, then the smaller of the two, then the bigger of the two, then positive infinity. And you're going to link them using, union. And that's your domain. We'll see at most 3, but it's the same story, nothing new. So what's the domain of f of x? You could say in English, all real number except for 1 and -1, or you could write it the way I wrote. And this contains all real numbers between -1 and -infinity without including -1. This contains all real numbers between -1 and +1 without including -1 and +1 themselves. This contains everything between 1 and positive infinity without including +1. I'm pausing here just a little bit, okay, to see what kind of questions people have. Okay, so when it comes to domain, one thing you have to watch out for is if the denominator is 0. There's one more one. I'm going to erase this. What about radical sign? You're going to see functions with radical sign. Okay, one thing, if I give you something like this, x minus 2. Okay, now inside radical sign, you cannot have negative. It doesn't make sense. Those numbers are imaginary numbers. Okay, we are only talking about real numbers. So whenever x is greater than 2, you're good. Now, when it comes to radical sign, I generally find the good guys, which ones are acceptable. So I would say x greater than 2, greater than or equal to, really, because 0 is okay. When x is greater than or equal to 2, it will make sense. When you replace x with 2, f of x will be 0. When you replace x with anything bigger than 2, this guy will be a positive number, and you're good to go. 3 minus 2 is 1, 1 is positive. So how do we write this? Using interval notation. So my domain will be My domain will be include 0, like so. 0 has to be included because of this equality sign here, right here, comma, infinity. Those are the two things you have to remember when it comes to domain of any function that we will encounter. If we encounter something a little different, of course, I'll talk about it, but I can assure you we're going to be encountering these two and a combination of them. And when we get to the combination, we will talk. Shouldn't be a problem. Any questions, guys? All right, guys, let me go to the next slide. All right, again, guys, this is a very easy topic, hilariously simple. If you add two functions, you just add them. Well, what do I mean by that? Well, when we do the problems, you're going to see when you subtract two functions, I'm going to give you one example. So suppose f of x is x squared and g of x is x plus 1. G of x is x plus 1. Okay, what's f of x plus g of x? Exactly what you would expect. X squared plus x plus 1. You add the two functions. What's the subtraction? Same thing, exactly what you would expect. You're going to replace this with a minus sign, replace this with minus sign. Okay, what about multiplication? Well, it's the same thing. F of x times g of x, and you want to have a nice multiplication sign. Nothing too counterintuitive. When you multiply two functions, you multiply x squared, put parentheses, x plus 1. And you can guess what you do when you divide the two functions. What's f of x over g of x? I'm going to write it here. F of x is x squared. You're going to write it. And g of x is x plus 1. And ideally, we should say, take it back. Ideally, we should say g of x is not equal to 0 because it's the denominator. The denominator of a function cannot be 0 because the function will be undefined. So nothing too fancy. Okay, so what they will do, they will ask you to add, subtract, multiply, and divide functions. Okay, fine, we can do it. There's nothing going on. Then they'll ask you what's the domain of this function. Okay, I'll pause there just a little bit. Okay, to help you process what we did. Just a little bit. All right, guys. The next topic from our same section is called composition of function. Again, they make it very, I wouldn't say they make it difficult, but when you write it, it looks very complicated, right? So bear with me a little bit, okay? It's not that complicated. So what's a composition of function? Okay, so let's take our same old two functions, okay? F of x is x squared. And it's something you want to understand. Okay, g of x is, I'm going to go back to my x plus 1. It could be anything. It's x plus 1. Now, what is f composition g? Just to let you know, guys, f composition g is written like this. And g, it looks like fog. G composition f is written like this. G first and f. Now, they're not the same. Okay. Some people say composite, some people say composition, both are accepted. Actually, they're saying both. So the point that I'm really trying to make, it is not multiplication. This, you see a big circle, you don't think it's multiplication. That's a different thing. You multiply the two functions, you're done. But this is called composition of functions. What does that really mean? Let me give you an example, then hopefully it'll make sense. This simply means I'm going to write the f function, but instead of x, I'm going to write g of x inside that f function. I know it looks a little complicated. Okay. The f function is x squared. Okay. Instead of x, I'm writing g of x, but g of x is x plus 1. I go here. I write x plus 1. And don't forget the square, because the function f squares everything inside it. What is inside it? Not x, but g of x. What's g of x? G of x is x plus 1. Let's do one more. What about the same two functions, but this time I'm going to do g composition f. Well, what's that supposed to mean? Start with g, inside, plug in the whole function f of x. And what's g? G is the second function, x plus 1, but instead of x, you're going to put f of x. But what's f of x? X squared. So they are two different functions. Don't think they're the same. And don't confuse this symbol. Composition symbol is an open circle. Don't confuse it for multiplication. They are two different things. I'm not going to worry about this thing too much. It makes a lot of sense. We will do them. When we do them, it will make more sense. We'll just look at the function and decide. If it has a radical sign, I'll be alert. If it has a division by x minus 3, x minus 4, I will be alert. Otherwise, all real number will be the domain. I'm going to pause here just a little bit, guys, okay? Any questions, guys, from anyone? Okay, guys, I think we're ready for some of the problems from your book. So let's do this. We assigned 1 through 12. Okay. This is not bad. So I'm going to do some of the ones really orally. I don't have a radical sign. I don't have division by 0. This will be negative infinity to positive infinity will be the domain. Same thing here. Okay. Same thing here. Same thing here. Okay. What about this guy, number 4? Well, number 4 has a denominator. The denominator is x plus 5. Now you ask yourself, well, can this be 0? Yes, when x is negative 5, the bottom will be 0. So how do you eliminate negative 5? You're going to say negative infinity to negative 5 union negative infinity to this. That's going to be the domain for number 4. Okay, now number 7 and 8 are a little tricky because let's see if we have any questions on 1 through 6, really. They're very easy. We'll work on 6, not 1 through 6. We'll work on 5 and 6. Okay. I need to. Well, 5 and 6 are easy. Really, we'll work on 7 and 8. 5 and 6 don't have any denominator. So the answer is this. Okay. So I'm going to erase everything, guys. New polypad. Okay. So be a little patient. I'm going to do number 8. Okay. This has a denominator. All right. So I'm going to set the denominator equal to 0 and solve for x. Why would I do that? Because I want to know what numbers make the denominator 0. And we have done it so many times. This is going to be x squared plus 4x minus 3x minus 12. You guys know how to do it. Now, we're going to set this equal to 0 because you want to know that the denominator, you want to make sure the denominator is not equal to 0. So you want to make sure what makes it 0. You're going to pull those guys out. So the answer will be x when x is 3. This whole thing is 0. When x is negative 4, this whole thing is 0. Those are the bad guys. Okay, by setting this equal to 0, you can say that. Well, what's the domain then? The domain, start with the smaller one, okay? Negative infinity to negative 4. Union, negative 4 to 3. Union, 3 to infinity. Done. That's your answer. Okay, and you won't be able to see it right away if it's a quadratic function like that. You have to set it equal to 0 and then you have to solve for it. And you can write it like this to begin with if you want to. I'm going to pause here just a little bit, okay, to see if people have any questions. Any questions, guys? Okay, let me see, guys. If you guys want to interact a little bit, that'll be very nice, actually. Let me see. Let me ask you, who's going to tell me what 10 is? In English, you can always tell me in English. I can write it mathematically. Who is going to tell me what question number 10 is? What's the domain of 10? And in other words, we are asking, is there a bad denominator? What numbers will make the denominator? They have two denominators here. They both have to be always positive or negative, but they can't be 0. What number would make the denominator of f of x 0, guys? Anyone? Don't be shy. Okay. Look, when x is negative 2, this will be negative 8. This will be 0. When x is positive 10, this will be 0. Okay. So how do I get rid of negative 8 is a bad guy and positive 10 is a bad guy. So my domain will be negative infinity to negative 8, negative 8 to 10, and 10 to positive infinity. And I'm going to connect them with you. You have to write U. If you just write the intervals, you're not going to get points on the exam. Give you a couple of minutes to process this. I'm going to do one more, guys. I'm going to do the very last one, and that will kind of finish this chunk. And I uploaded all the problems from this section on Blaze on MATLAB. You should be able to do it. So guys, we're going to work on number 12. Okay, you can replace X with 0. There's not going to be 0. You can replace X with positive number. This is not going to make it 0. You can replace X with any negative number. This will not make it 0. But this is the bad guy. I just have to focus on this. Okay. So you can say, you can do a little bit of math. You can ask yourself, what would make this 0? And solve for X. Then you're going to get X is equal to square root of 4. And that's plus minus 2. You can put a plus minus 2 here too if you want to. So when X is plus 2 or minus 2, you are in trouble. Okay, you don't have any value of X that'll cause you trouble here. But when X is plus 2 minus 2, you're in trouble. So how do we pull out plus 2 minus 2? Like we did before. So that takes care of this little chunk. I'll give you a couple of minutes, literally, and then we will we'll work on some of the other problems from your packet, which is not really that difficult of a section. I don't think so. Okay, guys, let's see what else is going on. We did 1 through, let me see which ones were assigned, 1 through 12, then 19 through something. Okay, it's the same thing with radical sign. Let's do some of those. Now, this thing will shut me down any moment. I will still like to squeeze in this part. So be careful. If it kicks me out, I will come back. So guys, it's the same story. These are radical signs. Okay, so I'm going to do number 19 first. Okay, I have two conditions. The radical sign tells me that X minus 3 must be equal to or greater than 0. Since X minus 3 is in the denominator, X minus 3 cannot be 0 because I will be dividing by 0. So I'm going to get rid of this equality sign. Now I'm going to conclude, this is number 19. I'm going to conclude that X minus 3 must be strictly greater than 0. And that means X has to be greater than 0. Okay. And inequalities work exactly the way you work on equations. How do you write all numbers greater than 0 using interval notation? You write it like this: 0 to infinity. Done. That's 19. Let's do 22 here. 22 is, this is not a denominator, but anything inside the radical sign has to be greater than equal to 0. If it is in the denominator, we don't count the equality. I'm going to write it like this: greater than equal to 0. And you solve for X like it's an equation. That's how you're going to do it. divide both sides by 7. And you're going to get 10. So x has to be, sorry, you're going to get 7. You're going to get 10. This has to be 7. So you're going to get 10. So x is greater than equal to 10. All right. And my answer is, what's my domain? The domain x is greater than equal to 10 would mean you include 10 because of the equality sign, infinity. Now, I would like to do, if I have 7 minutes, I don't see how it'll take me 7 minutes. I would like to do 28 for you guys, okay? And then we'll switch. I'll give you a couple of minutes to process, guys, okay? A few seconds. See if you have any questions. All right, let's try this one. The next one, 28. I'm going to save the word domain because I will use it. Okay, number 28 has 2 issues. All right, so here, the top radical sign tells me x minus 3 has to be greater than equal to 0. Therefore, x has to be greater than equal to 3. And the bottom sign, this denominator, tells me x cannot be 6. I'm just going to write it like this. X cannot be 6. So I have to pull out 6. It will be everything above 3, excluding 6. How do we write that, guys? We write it as follows. We start with 6, included because of the equality sign, go all the way up to 6. Start with 3, go all the way up to 6, but we don't want 6. We stop here, and we don't want 6 all the way up to infinity. We'll put a union sign. That's your domain for number 28. Number 28 is interesting. You have both denominator and numerator. Both are things that should alert you. Pause there a little bit. I think this is not a bad time to switch to our next session, and I'm not going anywhere. We're going to jump out. It's going to shut me down in 4 minutes. I'm going to jump out, come back. We're not going anywhere. See you soon, guys.